So here's a little refresher on how to simplify radicals. You did this in geometry, but I just want to remind you on the two different strategies you can use to do this. We're going to start by simplifying the square root of 54. So the first one I'm going to show you is the prime factor tree method. So what you want to do is make a little tree of all the prime factors of 54, and you do that just by splitting it into two factors that you know and keep splitting the factors up until they're all prime. So for example, 54 I know is 2 times 27. 2 is prime, 27 is not. 27 is 3 times 9. 3 is prime, 9 is not. 9 is 3 times 3. Both of those are prime. Now, what this allows us to do is to visually see any perfect squares. And we know we have perfect squares whenever we have a pair of the same number. So for example, we have 2 3's right here. So that means 3 times 3. Well, the square root of 3 times 3 is just regular 3. So this is equal to a regular 3 times the square root of the other factors that were not paired up. So like this 2 and this 3 are still under the radical. And so the simplified form would be 3 times radical 6. So radical 54 and 3 radical 6 are equivalent. The 3 radical 6 is simplified. All right, if we look at another example, a little larger number, radical 296, we're going to do the same thing. We're going to make a prime factor tree, find our pairs because those are perfect squares. I usually start with 2's if I'm not sure of a larger factor, but this would be 2 times 148. 2 is prime. 148 is 2 times 74. 2 is prime. 74 is 2 times 37. 2 is prime, and 37 is also prime. So now we look at our tree and find any pairs, because that's a perfect square, 2 times 2. Square root of 2 times 2 is just regular 2, times radical of whatever's left over, so that 2 times 37. There were no perfect squares there. So our simplified form would be 2 times radical 74. Okay, so that's the prime factor tree. Just to show you the other method, so back to the radical 54. The other method is factoring the 54 into two numbers where one of them is the largest square number that is a factor of it. So if we take radical 54, this is more of a guess and test in your mind and think, okay, what's the highest perfect square that is a factor of 54? Is it 4? Is it 9? Is it 16? Is it 25? Which one? Which is the highest one? And here, if you do some guessing and testing, you'll find that it's 9. 54 is 9 times 6. And the square root of 9 is 3. And 6 would just stay inside. So you see we get the same thing. Again, here you risk not finding the highest perfect square. That tends to be the risk. Whereas if you do the factor tree method, there's really no risk. Likewise, if we try the same method for the radical 296, here, again, I need to maybe guess and test with the calculator, try dividing it by 4, divide it by 25, divided by 16, divided by 36. See which of these is the highest perfect square, and we'd find that 4 is the highest one. It would be 4 times 74. And so the square root of 4 is regular 2. 74 just remains in the radical. So that's the other method. Again, it's a little more risky, but if you have good number sense, then it's a little bit quicker than the other method. Okay, well, why don't you pause and try this? I would like you to try radical 45. That simplifies to 3 root